So, welcome back, everybody. Hope you enjoyed the break. I hope you're enjoying the day. And I hope you had enough coffee today so that we can talk a little bit about energy, sustainability, and software code that we all write every day. Very, very quick, a little bit about me, because that's not the most interesting part here. I work at For You and Your Customers in Vienna. We are a software consultancy, which means that I work together with different software teams as well into providing solutions for their companies. So you will find me in many different roles in projects, but what I've been doing lately is mostly architecture design, data engineering, and also backend engineering. I like to say that I come from a Java background, but truth to be told, I've mostly been working on data for the past 3 years, so I will still keep the Java on the side. And beside of the work that I do with our clients there, my topic of interest has been for a couple of years now the intersection between sustainability in form of the environmental impact that our software code has and architecture design. So how can we combine those two so that the projects that we deliver, that software code that we deliver, is actually also environmental friendly, as much environmental friendly as it can be. And I started doing research in that area, but I found out very quickly that research is really interesting, but you do not reach this big of a crowds with research. So this is why I moved into this direction, being on stage, even though it's not necessary in my comfort zone, but it's something that I need to do because I feel that communities like this is where change happens. And talks like this, I hope they will spark something on that change. So yeah, it's not going to be statistics on this talk, but if you look around about the digital services impact on sustainability or on carbon footprint, you will see a lot of stuff, a lot of statistics like this one, 14% estimation increase by 2040, or what you will hear is probably also stuff like if digital services were a country, there would be the third biggest emitter that we have. So you hear everything like that, and maybe if you hear things like that, you have something that pops up in your mind automatically. What is it that is actually contributing to this increase? What are those parts? And then you might be thinking, data centers, obviously, AI, machine learning, the new hot topic, and then maybe also video streaming platforms or some specific domains that you already know. But what we automatically do not think is the software code that we write. So if we take that accumulation of all the software code and all the emissions that are coming from that software code, we are actually a pretty big emitter in that space as well. And what we also see is a movement on the regulatory level. So we see, for example, the European Green Deal, which is trying to make companies a little bit more accountable on their carbon footprint. And what does this mean with us? So why is this topic part of this software developer conference right now? Is that we provide digital solutions for companies. So if we have a customer that sells something, and part of those sales is coming from an e-commerce shop that we built for that customer, we will have to be accountable for that carbon footprint of that e-commerce web platform that we built as well, because our customers, they will not know how to measure that thing. So automatically it will fall back in our role as software developers. And we all know how regulations work. It will have a deadline, and we will be the last people to know that there is a deadline on that. So if you think about the data protection laws that we had a couple of years ago, you know how quick we had to do stuff. So let's try to improve on that as well. And now, before I make my point, I want to ask you two things. So we heard a lot about metrics today, and probably everybody here knows test coverage. How many of you do measure test coverage regularly? Yeah, quite much. Very good. And then the next obvious question, how many of you do you measure the environmental impact at any form? Thank you. Very good. But yeah, so this is what we see. And not only here, this is something that we see in the research as well. There is a huge gap between metrics that are well established in the software development lifecycle as we know it, and there is almost very few or no projects that actually measure the carbon footprint of a commercial digital service. So you might ask yourselves, why is that so? And there is a couple of reasons. I'm just going to state the most obvious ones here, starting with the awareness across the stakeholders and the executives. Now, with the regulation that is coming in, we know that this sustainability side of a business is getting even more important every day, and we have sustainability teams, but those sustainability teams are not made of software engineers. So they can decarbonize the business, but they cannot decarbonize our software. And having this lack in communication between management, between the upper management and between the software people, it makes it for us a little bit hesitant to do sustainability work on software level as well. So this is something that we have to work on. So to provide a little bit more information, how can we improve on that? And if we are required to improve on that area to make it a little bit more visible for our management, for our customers, we need also awareness across the software community itself as well. So my goal here, my whole reason of staying here today is to show you that you actually do not need to reinvent the wheel, do not need to make complicated stuff to be sustainable in your software code. And more importantly, you do not need to make any selling point or any great pitches to your bosses or to whoever wants to fill that work for you. You can use very much good practices that we have, as I will show you then, and then you can start an initiative within your company as well and do the work. And then the latest challenge that we have, the last one, is the data complexity. Generally, in the sustainability space, we have a huge problem with data because it's data that we are currently not collecting. It's massive amounts of data that we need. Different domains have different data. So we have a huge mess in there, which it will be for future us to solve. And now I would like to walk a little bit into how can we solve those issues. And before I do that, we need to have some key concepts. We need to have a common understanding of what means sustainability in software. And the folks over Green Software Foundation, it's an initiative by ThoughtWorks, they have done a remarkable job into providing us exactly this common understanding. They have provided us with principles, with patterns, with practices that enable us to write a greener software, enable us to communicate in a shared language with everybody who is involved around software development. And it also has a great impact for us as software developers as well, because without having to look at the whole system as a complex system, we know directly which activities are the ones that can provide for us a more energy efficient or a more sustainable product. And what Green Software Foundation says is that a green software is actually a software that emits the least amount of carbon possible. And the only ways that how we can achieve this least amount of emissions that are released is through 3 activities only: energy efficiency, carbon awareness, and hardware efficiency. So this is not supposed to be a theoretical pitch here, but I have to explain a little bit of the things here, so bear with me. Let's start with the first one. Energy efficiency. What it says to us is consume the least amount of energy possible. So we know it, software itself cannot consume any energy. The host where the software is running is the one that also consumes that energy. This also means that we have to take those physical devices into the consideration. And one concept that we have here is the concept of energy proportionality, which basically tells us what is the ratio between the power that is being consumed and the utilization of the server. So how much is that host doing at any given time? And if we look at this graph, we have 2 very important findings in here that we find. First of all, we see that even on 0% utilization, which means the server is doing nothing at all, we still have a power consumption. Translating it into practical stuff, think of all that code that is probably deployed somewhere that nobody touches. It's still consuming something. It's still consuming energy just for being there, just for existing. And similar things like that, all the pipelines that we have, all the tests that is there, but it's not actually used or does not have any productive meaning. Just by existing, it causes something to us. And then the second interesting finding that we have here is that if we double the utilization, meaning if we do twice as more within one server, it does not mean that we are doubling the energy that it needs to perform this extra work. So what this basically tells us is that the better we utilize a server, the more we do in one physical device, the more energy efficient we are. How is this explained? How is this translated is, if you're running on-premise, switch to a cloud infrastructure if you can. If you are already running on the cloud infrastructure, make sure that you use your resources as best way as possible as you can. And if you are considering of switching to cloud newly, or if you are considering to choosing another cloud provider, check metrics that they provide, such as the power usage effectiveness metric, which is a metric that all the data centers provide nowadays and tell us how energy efficient they are. So basically, the lower the number, the better they are at energy efficiency. So if you need to choose any, you have a project where you need to evaluate any data center, just take a look at that metric as well. And the third way of reducing that energy, of being more energy efficient, is by making code changes, of course. If you are able to change the code in such a way that it causes less CPU cycles or it decreases the energy that it consumes, you are good to go. If you consider a huge complex system with multiple teams that are working on that system and releases or deployments happening every 1 hour, every 2 hours, or every minute, you will probably have a very hard time into identifying or pinpointing where is that energy consumption coming from. And in that context, one super powerful concept that we have is green mining, which is a field in software engineering itself that helps us relate the changes in the energy consumption to the changes that were done in the code itself. Meaning that if we deploy something and we see that we have a huge increase on the energy consumption, we can just pinpoint this increase to a specific work that was deployed. And instead of targeting the whole system and seeing, okay, now what do? I have thousands of services. I have no idea what changed and what happened. I know exactly what changed because I know what was deployed within the last hour, and I know which tickets are possibly, or which works are possibly to blame for that energy increase, so I can improve on that as well. So this is a very powerful thing that we have. And then, as I said, 3 activities. Hardware efficiency is the next one. It's not only the carbon that is emitted during the usage of a software application, but it's also the carbon that is emitted from the creation and disposal of the devices. So when we are doing carbon accounting in software, we should not disregard the carbon emissions that are coming from the hardware itself. And how we can improve here is pretty easily expand the life cycle. The more you use a device, the better you will be in terms of hardware efficiency. And of course, also utilize the servers better. This is why the data centers are so powerful in this direction, because they share resources across customers. So you will have, in general, less devices that are physical devices that are needed. And then, last bit on the theory on this part, carbon awareness. Carbon awareness is, in my opinion at least, the most effective method that Green Software Foundation has provided for us. So what carbon awareness means is that we can use this principle to do more when electricity is cleaner and to do less when electricity is dirtier. So what I mean by that is, if we notice, for example, here, if we see that we have the same energy demand that gets fulfilled by different sources of energy. On the first column, we have, ignore the metrics, we have a much lower number than on the second column. And this is because most of the energy in that first column is filled by solar or by wind energy, meaning that the overall impact that that constellation has is lower than on the second column. For us in software, what does this mean? It means that if we can access this information at any time of the day, if we can know what is this relationship between coal, gas, wind, and solar, so renewable, non-renewable sources, we can use this and we can change the behavior of our application, or we can change the code to do more when we are having energy sources like in the first column. There are available SDKs that provide you that information. So basically they tell you, do it right now or don't do it right now. And if you have that access to do it or not do it, you can do, for example, something called as demand shifting, where you take resources that are placed in a region A, and you see, okay, region A is not efficient enough. I will move them into region B because region B has a better carbon intensity, so it does consume less. So you need to change nothing, but just by moving resources, you will be better. Similar to that, demand shifting. So now we do not shift in space, but we shift in we do a temporal shifting, what is called. So we say, okay, I know during the day, in many regions, I have solar energy. So I'm going to do the heavy load during the day. I'm not going to do it during the night when there is non-renewable energy there. Now, this is a little bit controversial because you have to always check with the business. You cannot just run heavy loads during the day, but still, it is a concept. It is to be kept in mind. And then, again, similar to that, demand shaping. In this case, we do not shift resources or shift code, but we change the code. We shape our code to do more when we tell it that, okay, you have a cleaner energy, do more. Do something that you like to do now that it has a lot of power. And these three combined already provide you with an infrastructure and with an architectural design that is already by default environmental friendly. So now that we have that, we come to the best part. What metrics and how can we measure it? Well, the obvious one, energy consumption. It's a direct link to the global energy usage. It's pretty simple. It's something that everybody knows at least what it is and what we understand under the name energy consumption. But it is not enough, as I said, because if you are running on renewable energies, it does not matter how much energy you are consuming, you are not emitting any carbon. So you should still not consume all the energy that you have, but at least you are not committing any carbon emissions. So to take the carbon part in the equation as well, we can calculate the carbon footprint, which basically tells you how much carbon, how much kilograms of carbon you are emitting at any time of point. And to take this a little bit further, we can consider the evolution of architecture. So if you have, for example, if you start a project from scratch and you decide, okay, I want to measure the carbon footprint of that project, what it will happen is that in the beginning of the project, you will have a very, very low number because probably your software has not evolved that much. You do not have as many users as you would have. And what we can do here is, again, a concept from Green Software Foundation. We can use this software carbon impact score, which basically it is a rate, which means we normalize that carbon footprint that we had estimated, and we put it into a relation to something, to any unit. For example, if you are running a streaming platform, you can calculate the carbon footprint per minute of streaming. And this makes total sense if you take it in an overtime comparison. So from the beginning of the project until the end of the project, minute of streaming, it's still going to be a minute of streaming. Just the carbon footprint is the one that it's going to change. Similar to that on an e-commerce web shop, for example. Do not calculate the total carbon footprint, but calculate the carbon footprint per order or calculate the carbon footprint per user. And you will have a much better comparison method and also a much more meaningful metric to use. And as for the how you can measure it, well, you could always plug yourself somewhere and just see how much power you are consuming, but that's not realistic. you can do the more realistic method that you do is you can choose any mathematical model or any tool that implements those mathematical models for you, and then just integrate it in the architecture that you have. And I will show you in a minute how does that look. And if a tool or if a mathematical model is still not available to you, you can use as a fallback a cost estimation. So you get the energy bill, you get some sort of bill from wherever you are running your applications. You can use that bill that you get at the end of the month to derive the cost, the carbon footprint that you are creating. This is the most basic calculation that we have. Energy that we have consumed multiplied with this intensity that I showed before. But let's leave it there. So here is how it would look like, for example, with Kepler in a microservice architecture. We have some sort of local machine that is doing any load into the system. We have a Kubernetes cluster there, and we have a load balancer that just forwards this request to some pods. Any of those pods will just reply to your request. What we have there is Kubelet as well, gathering metrics, performance metrics from those pods. And we have then Kepler, which is a tool that implements those mathematical models, implements those power estimations on Kubernetes cluster level as well. And they retrieve from Kubelet this information, do the calculations, and we can use then, as to put the big picture on the architecture, tools like Prometheus to scrape the data. We can put a Grafana in there somewhere, and then we end up with data in a dashboard. This is how it would look like. And what you can do is you just implement this once, you have it over the course of the project development. And what you would do is you would check it from time to time and see how are we doing, where are we in that relation. And if you're not running on microservices, we have something for monoliths as well. You can use tools, of course, but you can also do it yourself as I describe here. Let's assume you have a monolith with several services, and one of them is a carbon footprint calculator. What this does is, based on power consumption of CPU, network, memory, and disk usage, over a time period, it calculates the energy consumed for that time. And then using, again, tools like Climatic, for example, you can convert that energy to a carbon footprint, to a value, to an actual value that you can use. So now we've seen what we need to improve, how we can improve it, how does the architecture look like. And the next golden question is, how do we react? So how can we improve on that? Because we got a number now, so what do we do next? What is the next step? And we've heard a little bit today about refactoring, which is why I do not have now to sell refactoring to you or to anybody who is involved in software development, because you all know it. And one thing that is really so good about refactoring is that we can use it again to achieve a more sustainable software product. And I will give you a little bit, some examples. In 2023, I did a case study on solid principles. So basically what I did is I found some code on GitHub that was extremely bad code, and then refactored this code to fulfill those solid principles. I did one refactoring for each of the principles. I did a method. I had the same methodology as described in the monolith before to measure the energy consumption, and then compared the results, so the before and after. And this is what I got. So you see on the second column, we are somewhere into 2.13, not somewhere, but we are exactly at 2.13 watts-hour. And you see on the last column, the improvement in percentage. So we are between 39%, 32% improvement up to, for the interface segregation principle, for 40% improvement. And that is huge. So that is very, very huge, especially if you consider that this experiment, this research, was done only on, I think, 30 to 50 lines of code. I did not know, I have to look it up. But it was so small code that I was not even expecting to see any improvement as well. So I was expecting this experiment to completely fail. But it didn't. It showed us that we have actually something, we have something in our toolkit that we can use that actually brings a massive improvement, such as 40%, for example. And we have similar studies. So there have been quite a lot of studies on that direction to just investigate other best practices that we have or other refactoring techniques that we have. The latest study on April from Professor Noureddin, which is one of the biggest contributors on the research area in the intersection between sustainability and software, he analyzed the energy consumption of Gang of 4 patterns. And what he found out is that Gang of 4 patterns are energy neutral, which means they do not improve the environmental impact, but they do not make it worse as well. So what it means for us is that we can rely on this, we can just use it, we can use Gang of 4 patterns whenever we feel that we have the need to use them without having to doubt ourselves if we are doing something worse for the environment or not. So this is safe to use. Another study in that area, a little bit controversial one, microservice versus monolith. So this was also a big one. Yeah, well, you can assume microservices consume more energy than monoliths, mainly because of the communication energy consumption that is needed there. But this does not mean that we have to go back to monoliths. Not at all. What this means is that we should pay attention more on how do we slice those microservices. So when do we create a new microservice, or when do we decide to utilize something that we have even better? I've worked in teams where the decision made on creating a microservice or not was just, okay, who has free capacity and what programming language are you good at? So we are going to create something new. So this is not the way to go. This is, if you think of it mindfully, then you will find in that toolkit really, really powerful stuff as well. Another super easy, really, really easy example, but that it brings actually a great benefit as well, using other techniques, for example, in the group of composing methods, such as the extract method. It is used usually as a solution to duplicate code and to long methods. And if you just, in the example that I have provided here, you can still see an improvement just if you extract this Spring functionality and calculate the total item price in separate methods, and then you can make them available for further use. And why this works is that because CPU cycles are reduced by that, and then this allows also better method inlining or caching or other optimization mechanisms that we have. And this is especially helpful in large-scale applications. Similar to that, in another group, moving features. In the group of moving features, we have the move method, for example, which solves the problem of a method that is being used more in other classes than in its own class. So if you see something like this in your code base, just move that method to the class where it belongs. And why is this more energy efficient? Is because it removes that need for creating an object every time that you need to use that method. So just move it around and you are already more energy efficient. Simplify the data structures. So this is, again, a pretty simple one. And on this one, I did another interesting experiment on a customer project that we had. When Azure released first their carbon footprint dashboard, they have almost all cloud providers now, they have those carbon footprint dashboards as well. And they provide you information on resource level, how much carbon you are emitting on that resource. And we had a lot of SQL servers in that project. And I saw one server that was massively committing carbon. So we thought, okay, what is going on there? And it was a legacy system. So it was one of those systems that it was created many, many years ago. It got filled with data and never cleaned up. So what I did is I cleaned it up. I removed everything that I thought it was not necessary. I then just, every attribute, I took a look at the data types. I took a look at the data types and then changed those data types when it made sense. I would see things like, for example, it is clear that the value, it's a flag. It can either be 0 or 1, but it was saved as a string, it was saved as the text, it was saved as integer. So you would see all the constellations. So change it. Allow it to have only that binary value that it can have. It is not more stable for your project as well, for your application as well, but it will also cost you less energy and less storage and everything. So just by changing those things, we saw then within a 2-week or 3 weeks range, we saw really a decrease in the carbon footprint of that single server as well. And the good thing that this triggered is that other people saw it, other people got interested in that, and then we started doing it at scale. And doing it at scale, it brought the thing to us, to our project, that it reduced the general carbon emissions of that project without us even needing to discuss in bigger groups how are we going to do that, how are we going to plan, or how are we going to convince our product owners or stakeholders that we need to work into that sustainability work. So we just did it, and then everybody was happy after we presented those results. So looking at the time, I was pretty quick, nice. I would share some key takeaways from me. And I've put them in a sequence. It does not mean that the one is more important than the other one. For me, they're all important in the same. But the first one is something that I really like to say it out loud every time that I get a chance. Sustainability in general, but also sustainability of a software, is not an all or nothing problem. So it does not mean that you have to go net zero right away. It does not mean that you have to build a new project and do it the most perfect way that you can think of, or the most state-of-the-art way that you can think of. It is enough if you just start. It is enough if you just bring it up as a discussion, because sooner or later there will be a chance to integrate those principles, to integrate those stuff into your design as well. And even if you cannot measure the carbon footprint, or you cannot do this environmentally impactful work, you can still find other things within the sustainability space or within the software space on how to make your product more maintainable, how to make sure that your product or the solution that you build is not replaced every couple of years, and the whole need for doing exactly what you did right now does not disappear again. So there are a lot of ways to think of it. Another point for me that is really important is environmental impact of any software solution. It's not something that is considered on a time-boxed zone. So you can start talking about it at any time, but you will be much more efficient if you start talking from it from the very beginning of a product. So if you start from the requirements engineering phase and take a look, really pay attention into understanding what do your customers want, what will happen is that you probably will get much better MVPs out of it. You will get the real business value of your customers. And this means that you will not have those features somewhere built that nobody uses. You won't have that code that is deployed somewhere that nobody uses. So by starting from the very beginning, from the requirements, through all the software development lifecycle phases that we have, you will be able to achieve small improvements throughout the whole way, then in total will make a very, very big improvement for you as well. And then I said it at the beginning, you do not need to reinvent the wheel. You can use what we already have in our toolkit. You can rely on the best practices that we have. Again, Green Software Foundation, they provide us a catalog of best practices. So wherever you are working on web development, you are working on AI and machine learning, for example, or you are working on cloud optimization, you can check out their catalog of best practices and see how you can solve common problems, because they are proven to work, they are proven to be more energy efficient, so why not just use them right away? So, yeah, consider the best practices, said that. And then, the last but not least, measure it. So for me, the most important thing here is measure it. It does not matter if you measure all the parts of your system. It does not matter if you start with a single component. you have to measure it. Once that, if you do not have a measurement method in place, you cannot know if you are improving. You cannot know at what state you are right now. And most of all, you cannot really evaluate your work, what you are doing. So measurement is the most important thing right there. And I'm pretty sure there is a software law about that as well, because we have so many metrics in our place, but measure, 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 and I cannot say that enough, so yeah. I made it within 10 seconds. I'm very proud of myself. I had so much content. So yeah, I'm very happy to discuss with you then later on, but also if you face any challenges in any project that you are working on, feel free to reach out. I'm very happy to support on that area, and I do it all the time. So I've seen a lot of stuff. Do not hold myself for an expert, but I'm happy to share whatever I have in my background with you. So thank you very much.